Okay, so in this part of the video, in this second video, I'm gonna talk about pages 6 and 7 from the homework in section A4. So back to the cycle shop. The equation for the number of seats, remember it was B plus T, or bicycles plus tricycles, equals 24. So I know that tricycles is my Y value, and bicycles is my X value. So I'm going to use this formula, X, because there's one seat for every bicycle, plus Y equals 24, right? And then the number of wheels, well, a bicycle has 2 wheels, so the multiplier is 2. Tricycle has 3 wheels, so the multiplier is 3. Altogether, I may not know how many bicycles and tricycles I have, but I do know that altogether I have 61 wheels. And this comes from the equation 2b plus 3t equals 61. So they say then show all the work necessary to graph these two equations. So that's what we're about to do. Okay, so the first equation, x plus y equals 24, I just found the intercepts because I thought that was pretty easy. You know, a shortcut to finding the intercepts is that you say, well, first when y is 0, or whichever one you choose to go first. Y is 0, x is equal to 24, and when x is 0, y is equal to 24. Bingo! Easy, easy. Okay, so the next one, 2x plus 3y is equal to 61. We can solve that. We may as well solve it using the x and y intercepts because we're in standard form. So 2x equals 61 is going to be our first equation because we assume y is 0. Divide both sides by 2. X is equal to, that's going to be 30.5. Okay, and then we cover up the y, or pretend like the y is a 0. And we say 3y, I'm sorry, we cover up the x, or pretend like the x is a 0 value. 3y equals 61. So divide both sides by 3. Y is equal to 20.3. 20.3 repeating technically, but we'll just say that. So to graph these, you need to just find the spots on these are the intercepts, remember, so we're just finding these locations on the axes. So first line is both x and y intercept at 24. So we're going to draw a line from 24 to 24, like this. And then the next one is x is equal to 30.5, somewhere in there. And then y is equal to 20.3, somewhere in there. Okay? And then we're going to draw a line. About like that. So our location is going to be somewhere around this 12, was when the bicycles are 12, and the tricycles are about 12, maybe 13. So we're going to find this out. Actually, I think bicycles end up being 11 and tricycles end up being 13, if I remember. So the deal is with the point of intersection is how many bicycles and how many tricycles are in the shop. So you're finding when each scenario is happening at the same time, what is that one set of coordinates that the outcome, those values work for both lines, because all these values work for this line, this value works for that line, that one does, and all these values on this other pink line work for that line. But when both of these things are happening at the same time, there's one little set of values here that will make an intersection, and they are both going to be happening at the same time. Okay, so I believe it is that the bicycles are 11 and the tricycles are 13. It's just not drawn super well here. Okay, we're doing this later. You can write later on it. And then here, we start out with something pretty straightforward. What value of x makes the following equation true? Well, we just solve for x, so there you go. Now we're going to take these two equations. Notice how these match, right? And we're going to graph both of these lines. So we're going to see if it kind of works doing it both ways. So this is using substitution up here, and this is using graphing two lines to find their intersection. And again, for me, the challenge is just drawing the lines well. I'm assuming you probably have the same problem. So let's just go ahead and see what we can do. I have the first line graphed here, and already it's not great. This should be kind of over a little bit more. Second line, y equals 8x minus 9, so my intercept is here. I count up 8, 1, 2, 3, 4, 5, 6, 7, 8, and over 1. Oh, look, that happens to be one of the points on my other line. I know it for a fact. I don't even have to try to guess. So let's draw that in. Okay, so these two lines intersect. You see that one point right there? That's where they intersect. That's where, with those two values, that's the one location where both of these lines can live in harmony. So, and that location happens to be 1, negative 1. So when x is 1 and when y is negative 1. Well, look at this. So our x is equal to 1 here. So we know this is probably a match. Where do the two lines intersect? At this location. What's the significance? I think I just talked about that. Okay, how does the point of intersection relate to the x value from problem 1? Well, the x value is the same thing. So basically we're taking these two equations, setting them equal to each other, and we're finding that our x value is going to be 1. And that's it.